Hi, everyone. I'm Josh. I'm the founder, CEO at Astria. We're building the shared sequencing network. So shared sequencing, speedrunning the Endgame. So this is stealing a, line from John Charbonneau's, I think, most recent post, maybe second most recent post. But generally, the question we're going to try to answer here is like, what is a sequencer? And so we'll use this very rough model here for like how blocks are produced in a blockchain. And this is kind of the same, whether it's a rollup or not. We can add some extra things, but generally you have transactions come into a mempool. I'm going to extract away whether we're thinking about a P2P network or whatever. We're just going to say there is somewhere that unordered transactions from users go. These are assumed to be signed by a user. Some process by which these transactions are ordered into a block, and some process by which these transactions are executed. That's going to update your state database and give you a resultant state root, probably a Merkle root, whatever Merkle tree, kind of pick your poison there. There could be for rollups, an additional step of posting data to a, DA layer or, whatever you want to call it. You could also generate a proof using some kind of, ZK method and post that to, we'll just use the term settlement layer here, but not kind of relevant for this talk here. So when we talk about sequencing, and there's kind of some distinction here, generally for like the contents of like this talk, we're talking about just the ordering step. And this is going to track with at least like Arbitrum's terminology. If you read through the Nitro white paper, they have a nice section, I think it's section 2, where they talk about the distinction between ordering a block and validating it or like posting the state root to a given settlement layer for like a bridging thing to essentially make an attestation to a light client over what the newest updated state is. We're just talking about the ordering step in sequencing. We'll call this the execution phase. From like Optimism's thing, I'm not sure they actually specifically separate the terminology in that, generally, right, when you think about a block being produced, you think about ordering the transactions in the block and then actually executing those transactions through whatever your kind of deterministic state machine is. But again, for this talk, we're just going to think about ordering. So why do we have the sequence here, right? Fundamentally, it's because of speed, right? There's now this concept of like base rollups. It's not really like new. This has been discussed for a long time of the idea of, well, we'll just post the transactions to the, base layer, the DA layer, whatever you want to call it directly. And then there will be some out of band process by which a node chooses to pick up these transactions, which are probably serialized or compressed through some format. And they will essentially be from the base layer's perspective, context free, in that they're just like raw bytes to that base layer, call data on ETH. For Celestia, right, that's just the only way it can understand them, right? And then you have some out-of-band process that actually picks up these transactions and, again, orders them. It could choose to inherit the ordering of the base layer. If there's like a contract on chain that has like a FIFO queue or however you want to do ordering on your base layer. And then it actually executes them and updates the resulting state root. And then that full node of that rollup is where end users actually interact to get an updated view of the state DB. That would be like their RPC connection, as well as like a state root to ensure that they're actually at head of the valid chain. But what we realized is that fundamentally users like kind of fast UX. We can, go back to like the early like 90s research. Google has actually like a lot of good resources on it because they use it for PageRank. And because the relevant thing, right, is like users generally, when they click a button, like to get a response between 1 and 4 seconds. If you're thinking about like, a phone or like a local UI, the latency gets much, much lower. But generally from a web end, front end, you click a button, it takes more than 4 seconds. The user's mind kind of goes to like, oh, this is broken. It's probably not working. So when we talk about this, if a user clicks, sends the transaction and has to wait like 12 seconds, or, that's for 1 block. If it's 2 blocks, it didn't make it in. They start thinking like, okay, I clicked the button. Did it work? Did it not do anything? I'm going to hard refresh my page. I'm going to click the button again, right? So fundamentally, these rollup sequencers are providing a speed because how they work in like the existing kind of centralized chains is that you have a user, they submit a transaction to the rollup then takes that transaction, gives the user and says, hey, I got your transaction, you're good, and then gives them the updated block at a time that is assumed to be dramatically faster than a data availability layer. Right now, this is essentially like a FIFO queue on both Optimism and Arbitrum, gives you a soft commitment back. The rollup sequencer then does batching to the DA layer. There's also some optimization on that batching from like compression. This is relevant to when you think about Celestia, Avail, EIP 4844 in kind of blob sizing and minimum blob sizing for kind of efficiency of data storage. But then you get a firm commitment. So this is roughly kind of how we're going to model a sequencer at the simplest case. And it's for speed, right? So this is kind of like the current problem as we pose it. We're not going to focus too much on this, but like this is like the joke, right? You've given users fast stop confirmations, but essentially like what you've done is you've centralized this sequencing component to say that like the valid source of the chain is only determined by like one node and specifically like one actor within the ecosystem. This is the sequencing node that is usually run by like the development team, right? So when we say shared sequencing, what is that? What does the terminology here mean? Going to like a larger diagram here, if we can think about like a user and they submit to like a rollup RPC, this is, Infura, Pocket, whatever, pick your poison of, RPC provider. But this is where you're going to submit, connect your MetaMask wallet, connect, Foundry Cap, whatever, submit your transaction. That goes into the shared sequencer. And the idea is that to go back to that original diagram of you have, mempool transactions that are unordered. That is what is going into the rollup RPC. All of those unordered transactions go to a shared sequencer that does the ordering phase. And then there's kind of not shown in this diagram because it's messy, a return path wherein an ordered block is passed back to a rollup. It executes it. Now you have your updated state DB and a resultant state root, right? You still get your batching to a DA layer for very low throughput rollups. This could be beneficial if you're not reaching some critical threshold on kind of like a minimum block size of a DA layer. This is more relevant for 4844, which as I understand is relatively large block sizes. It's like only like 4 blobs, I think, per block, but I'm not an expert on 4844. This is what we need here, right? And the kind of key component here is that the shared sequencer is implicitly, at least in our terminology, a decentralized sequencer, meaning it has like some kind of leader rotation. There's not a single node that is responsible for determining kind of the ordering of the block, or there is one, but it is for a given block time. And then at the next block time, there's a new leader for that round, right? Decentralized by default, MEV driven design. It's all PBS. And this kind of goes into how we think about, I guess, MEV driven sequencing, or kind of like familiar with like the MEV supply chain order transaction flow, right? Broadly, we can think of it. This is like the full stack of how like an MEV PBS enabled rollup would look for. You have a rollup RPC. It goes to this mempool again. These are unordered transactions. You have a searcher or a builder. These can logically be thought of as like one entity here. And then they're going to actually produce a full block, and your rollup proposer, right? This could be a centralized component, decentralized. This is how like ETH works today. It's actually just going to accept the block. About 90% of blocks right now are accepted through this method. And they're just going to accept the highest bidding block. And then it's still going to do the batching. You're still going to get a soft commitment from that. You're still going to get a firm commitment. It just now has MEV in the order flow. And Dogan, I saw your question. We can get to that after kind of I do a quick 10, 15 minute run through here. If we think about this MEV supply chain in like a shared context, it's actually for like one rollup, not that structurally different. Again, you have a rollup RPC, your unordered transactions go to a mempool. This can expand dramatically, but I'm going to try to avoid getting to kind of the back half of this talk there. And then you have a shared sequence proposer, again, taking the blocks. The big thing to think, right, here's just a quick comparison, right? Fundamentally, we're essentially swapping out the mempool and the proposer. The RPC remains the same. This is roughly the comparison between like a centralized sequencer. It doesn't have to be explicitly centralized. This can be a rollup specific sequencer. And like a shared sequencer implying that it's used by like multiple rollups, right? If we compare this, kind of the reason for like this diagram is like the idea is that if you have one rollup and you want to make a second rollup, you have to duplicate these supply chains, right? You have to have twice as many RPCs, new mempool, new set of proposers. You think about like the shared sequencer, right? You can have just the rollup RPCs, and then you only have one instance of this supply chain. I think some of the questions we'll go into, we'll discuss kind of the trade-offs and the design spaces within this. But there is at least, a possibility of like a utility for not duplicating kind of all of the infrastructure components if you're trying to actually do a very similar thing across multiple rollups here. When we say a shared sequencer, what's kind of a key thing that it's enabling? We argue it's a single place where block builders can settle multiple rollups. So going back to this slide, right? You can have multiple rollups go through the same supply chain. And when we say settle, it means that you have a proposer that is assumed to define, I'm going to use the term like the canonical ordering of the chain, right? Obviously, there are like forks and whatever, but it is for a given fork choice rule that is opted into by users who are accepting this as the canonical fork from their view. It is the proposer that when it signs a block says this is the next valid block in the chain per the leader selection mechanism, whether this is something like, a Gasper or a Tendermint or theoretically like a proof of work thing. It is a single place that it can settle multiple rollups to it because you have one block that contains multiple rollups.
Well, I think that was a really helpful overview. I guess like one thing I want to start off with just like a base layer is like our fellowship cohort is pretty diverse in the sense of like people are working across all the different verticals, DeFi, consumer, infrastructure. For those people on like the application side, I'm curious how you think these conversations happening in the shared sequencing area impact them the most.
Yeah, I mean, there's like really like two options I'd say, right? It's like, are you an application that believes you would be benefiting from doing an application specific rollup, whether that's running your own sequencer or whether it's opting into a shared sequencer, which the argument is that like it reduces the amount of infrastructure work you have to do to kind of stand up your live rollup. There's the other category of just rollup kind of proliferation, or like the development of it could lead to a wider variety of, I'll say, VM based rollups. And when I say that, it's the idea of like an EVM or like a fuel VM or a Cosm WASM VM, or whatever, specifically a VM that is ideally not permissioned, but it could be permissioned, but it is user modifiable to update the kind of state transition rules of this, right? Something that allows you to deploy smart contracts or something to it, rather than something that is only updated, the state machine rules are only updated via like hard forks and kind of native code changes. But the kind of creation of those may enable new applications to be developed. So it generally increases the kind of design space. Again, you can choose to use an application that may benefit from more vertical integration here in the VM layer, or you could have more novel VMs that are more easily developed, because the barrier to entry via what infrastructure they need to build themselves to kind of get something out the door is lowered. That leads to kind of like we'll use a trade term like a Cambrian explosion, right, of development in state machines that may unlock new potential for applications that can take advantage of that.
Got it. I guess like moving on to like value capture, which I think is like a big part of this question. Like, what are the different business models that shared sequencing can kind of bring about? And then I guess like, could you talk about value capture more broadly? Like, do you see shared sequencing as the primary way a lot of these like sort of roll up frameworks will accrue value?
Yeah, I mean, I think when you think about like value capture, like it's a pretty broad question. It ties into kind of the question for like Nick, right, on like value accrual in the modular stack. This is a question that's been kind of asked at, I think every conference that's had like a modular panel for the last year at least, right? Fundamentally, how I see value accrual is like kind of standard, economics thing, right? Like you have a set of parties, each of them would like to maximize their portion of the value that they capture. Who has the strongest negotiating position, that person is presumably going to be the person that captures the highest amount of value. So when you kind of come to this question of like, okay, how are the shared sequencer kind of like accruing value or capturing value, right? We also want to think about like who is capturing the value here, right? And so when we say the shared sequencer, right, it's like a question of like the shared sequencer is a decentralized sequencer. If we relate this to like Ethereum, right? Ethereum could be thought to be capturing a lot of value from MEV, but really it's the proposers that run nodes to produce blocks on Ethereum are capturing that value. By and large, that money that is captured in, we see an MEV spike and some validator gets 50 ETH on, one block they produced because they happened to get lucky. That was where, an arbitrage game occurred and they were the one that got assigned it. That's not necessarily going back to like the ETH protocol. Some of that may lead to kind of, higher demand for block space, and you have a fee burn, fee capture, whatever that goes back. Shared sequencer is an implicitly decentralized thing, has a similar thing, right? The proposers of the shared sequencer may be capturing a relatively high value if there is a large amount of kind of MEV and thus kind of leaked value from ordering and like information asymmetry generally in transaction submission from an end user to kind of the we'll say like, I guess, sophisticated user, a searcher, an arbitrage or whatever, and their ability to capture that. But what we see in kind of steady state is that somewhere in the ballpark of 90% of that value pushes to the back of the stack with the proposer. I think the jury is still out, and it hasn't been around long enough, nor have I looked at the data to see what things like MEV share kind of push back up the stack towards the user's amount of capture. But I do think we fundamentally see some kind of balance there. I don't think shared sequencers see any kind of large divergence in this beyond it is a decentralized blockchain. Some entity is kind of in charge by way of your leader selection rule, right? We are using leader-based consensus mechanisms. One party has a monopoly for that block. That means that they are the most powerful economic actor in this space. They are most likely to capture the bulk of the value here. Same as any other blockchain with a leader-based kind of leader election rule.
Got it. Yeah, that makes sense. I guess bringing it back to something that I think a lot of fellows have asked about before is like, as the app specific block space concept is taking off, a lot of dApp developers are kind of going towards rollup as a service providers to help launch their rollups. These services obviously make it really easy for teams that are bandwidth constrained to have their own block space without having to think about all the like complexities of running one. So I guess I'm curious, like, I feel like these roll up as a service providers are in the flow of a lot of value if they kind of start running their own shared sequencers. So I'm curious what your thoughts are on those products, and do you feel like they're crucial to like the proliferation of the app specific roll up thesis?
Yeah, crucial. Yeah, they're probably crucial. Or they're certainly very important because they exist already, right? Fundamentally, they're like onboarding tools, right? And you go from like any business stance, right? And you say, okay, we want to get new users onto a new paradigm, right? You want to try to reduce the friction of them doing that, right? We essentially saw like arbitrage and optimism, and I don't think it's incorrect to say that like the amount of resources necessary to get those projects off the ground to the place where they are now was equivalent to kind of any other L1 project circa 2020, 2021, go back to 2019 maybe, right? It was this very, very large multi-round fundraising effort to launch. If we want to see this kind of large N number of rollups, you can't say, oh, every rollup that needs to launch needs to go raise like $100 million of capital and do like 2 years of R&D work to get it off the ground. That's just like not going to scale that well. So what we want to see from these roll-up as a service providers is very much the same thing we've seen in cloud provisioning, right? When people ask about roll-up as a service providers versus running your own validators, that the analogy I like to use is think about like cloud versus like on-prem, right? There's no mystery that cloud is charging you like a very high margin. Like I'm biased. I worked in like Google Cloud for like 4.5 years. Like it paid my bills for like a while, right? But they're charging you high margin, right? On like raw compute and storage, they may be charging like 60+% margins on that. But the reason they're doing that is because you're like a web developer and you say, I want to go launch a website. And you say, well, okay, maybe my like CPU cycles cost me 3 times what it could cost me in some colo facility, but I'm a web developer. I don't want to go figure out what it entails to go call up Dell, get an order on some servers, figure out what my load requirements are, call up a local colo facility, maybe too, and do all of this infrastructure work. Once there's kind of like this available option to say, well, you could just click a button and yeah, you're going to pay more, but that's fine. You can just click the button. You can think about, how that's hitting your bottom line and your marginal cost later. You can get something off the ground. And that's really, I think, the correct analogy to see here. As we tie this into shared sequencing, importantly, like Astria, the first deck that had like the name Astria on it would like for like a roll up as a service. I think we call it like rollup SaaS. We didn't have as clever of like an acronym back then. Fundamentally, the reason we chose not to do roll up as a service was this kind of anxiety over the centralization versus decentralization, right? Not to kind of like, put like a bugbear out there, right? But like, if you're a centralized, roll up as a service provider and you get like 20 roll ups on you, and like the SEC eventually gets around to like learning what the hell a roll up is, right? And they come around and they're like, hey, there's just like one guy that's running like 20 of these roll ups that are doing like unregulated arbitrage trading on tokens that we view as securities. And they're running them all at like AWS, like US East in Virginia, right? They're like, yeah, we're just going to like send one letter. And now 20 of these roll ups are offline, right? And so that was our fundamental concern over these roll up as a service providers. And I think structurally, you could see like a shared sequencer as some kind of decentralized extension of a roll-up as a service provider, right? If we go to kind of the diagrams I was showing, right, we still have these like roll-up RPCs kind of in the stack. And that's similar to what you'd have, an Anthera or a, Alchemy that would be running on your behalf. Very similar to what, your Caldera or your Conduit are going to be running, right? They're going to take, this OP guest, they're going to take OP node, they're going to take OP batcher, right? They're going to put that inside of like a Terraform config, probably in a Kubernetes cluster. They're going to deploy that to AWS, Azure, or GCP, and they're going to stand that up. And then they're going to say, here is how you can modify the OPGS to do the specific functionality of your rollup, right? We can work just as well with that. The kind of tie-ins that need to happen is that on transaction kind of submission to this rollup node, your transaction flows rather into the, what I'll say, the rollup specific mempool. It just flows into the shared sequencer mempool. And then on what I'll say, like what we determine as like the read path internally, right? It's just when, part of the crank of like the block kind of this rollup says, well, okay, now I have an ordered block. I want to update my internal state representation. That just needs to be able to read a block out of a shared sequencer. So from like a kind of infrastructure perspective, there's compatibility between these things, right? Whether or not we see the rollup as a service provider go to shared sequencers, whether we as like a shared sequencer project feel the need to go to like build our own rollup as a service thing. I think that's fundamentally like a product and a market question, because it's really this who is capturing a user, right? The rollup as a service providers right now, by way of kind of doing the centralized option as their kind of go to market right now, have an easier way to go direct to customers and get something off the ground, right? And so it's fundamentally a straight up like, do you build a kind of back end deep tech and say, we're going to build kind of long term and we'll go to users later? Or do you try to acquire users up front and say, after the fact, we can go kind of make our tech and build it into what we need it to be for some long term kind of maintenance of all of these customers' needs?
Right. That makes sense. I didn't realize that you guys were initially going to build a rollup as a service company. I think that's really interesting. I think this dovetails nicely into Nicole's question. He was basically asking, like, you talked about shared sequencers, value capture, but how do you think about sort of like revenue and value capture for Astria itself?
Yeah, so I mean, like from the team perspective, and this is like a broader question, I guess you can say to like any blockchain project, right? Is you're running a decentralized network, like how are you capturing value in it, right? There's really like a token, right? It's kind of like, the quiet part we try not to say out loud, right? But fundamentally, you're running a decentralized network. It is doing some kind of consensus mechanism. It has a decentralized set of actors by way of it being this kind of, again, decentralized, right? It opens you up to kind of attacks by, unknown actors, right? It's like Sybil with the resistant attacks, right? Why do we have tokens natively issued in the chains, right? Is because we want to have like Sybil resistance mechanisms here. No one else, to my knowledge, has come up with kind of a more clever metering system than saying the chain has some internal state mechanism that says you have to pay this much. And we just set that as like the floor price. You can spam me, but it costs you that much. And then we get into questions around censorship definition of what is the difference between spam and censorship, right? And like at some abstract sense, there's no kind of observable difference. From like how we view value, like fundamentally we're building like a network. That's how we view it. We view ourselves largely as any one of these L1 kind of model things. We are building a network. We would like to get users, whether those users are probably like projects rather than, it's more of a B2B play than like a B2C play. And there is really no B2C, I guess, still an infra stack, right? But it's less app devs, maybe more rollup devs, whether those are the same thing. It's still like an open kind of design question. And then the idea is that by way of producing those things, there is some kind of like pre-mine, whatever, right? It's standard fund, we're like a venture thing, right? Like standard fundraising model. You go to launch a network, you're going to go raise capital. You're going to sell some future token interests to some VCs. That's going to let you get enough capital to go build the project. You're going to then launch a token. Those future token interests go some to the internal team, some to the VCs, and then you get dragged on Twitter by Ethereum people for having a pre-mine. That's generally how we run the monetization here.
Oh my gosh, that's really funny. I guess like kind of going off of that, if your users, let's say, are like app specific rollups, I'm curious, like, what are the main benefits for app specific rollups to not want to control their own sequencers? And I guess as a part of that, can you kind of talk through the network effects of shared sequencer networks? And the reason I'm asking this is because actually several of our fellowship projects are thinking of building their own rollups for their apps. So I think this is super relevant for them.
Yeah, I think fundamentally it's a question of kind of like differentiation in like a market, right? So the question is like, do you view being able to differentiate on your sequencer, maybe having like a better sequencer than one of your competitors as a differentiated advantage for your end user experience? If you don't, then there's a question of saying, okay, well, here is the market price I'm going to pay to utilize a shared sequencer. And that gives me infrastructure of this quality with these characteristics. And then I don't have to think about it anymore, right? I do the integration. I get on a call with that team. I go through their docs. I'm off to the races. But you had to make some fundamental trade-off space there, right? Because it's not going to be this infinitely complex system that can satisfy all demands. I think the biggest parameter to kind of think about, if we think about like a single parameter here, there's maybe two, right? It is going to be block time, right? The shared sequencer, like definitionally, have to have like one block time for all the rollups that goes through it, right? If you say, well, I want to have a different block time than this other rollup, then you're going to have to use a different sequencer, whether it's a different shared sequencer that's saying, hey, we're marketing as a half-second block time shared sequencer, or we're a 2-second block time shared sequencer, right? You can choose different ones, or you can run your own centralized sequencer on that block time, right? This is what we've seen with, Say has done a lot of work on optimizing tenderments to have, I believe they're looking at like a half-second block time, because they view that as a differentiated advantage for their DeFi chain. I think they're building like a DEX on it, but like, what do they view that as a differentiated advantage compared to other things, right? Obviously, it's like Solana has like a 400 millisecond block time. They view that as a differentiated advantage. However, I do think, and kind of like, not to like show us too hard, right? There's a large, range of like rollups that are valuable by saying, oh, we have like a 1.5 second block time, and so do like 15 other rollups. They all have a 1.5 second block time. And actually, we're differentiating on something on the state machine, whether it's we're using the EVM, but making some specific modifications, a la like stylus style, kind of native, pre-compile-esque modifications to the EVM. And you say, we believe we have some alpha in, we've built a more interesting one on the state machine, right? Or you saying, well, we've actually said we're not going to build what I'll say like the consensus level kind of infrastructure. We built a novel state machine, and we were able to invest more resources in building a newer state machine that's differentiated this way because we chose not to develop the consensus side. You saw a little bit of movement this way, right? I think if you just look at Cosmos SDK and Tendermint in general, right? Every Cosmos SDK chain that says they're going to use Tendermint, they have a little bit of modification in like the block time, but by and large, they're accepting, I'm going to take a safety bias, relatively low cap validator set PBFT consensus algorithm, and that is good enough for me. I'm not going to go try to be Avalanche and have like the best consensus algorithm, by their kind of measures. You say it's good enough, and I'm going to use that, and then I'm going to differentiate on my state machine logic, and it's kind of an extension of that.
Yeah, that makes a lot of sense. That's actually really helpful. I want to make sure we also get to cover some of the audience questions. Christoph, I thought you had an interesting one. Do you want to unmute and ask your question about geographic distribution?
Yes. So say you want to have a trade from just London. So if you have a single sequencer, it needs to go to the location of that single sequencer. Can you just route it to the just nearest location of the sequencer?
Yeah, so fundamentally, I don't think it solves kind of the problem of like essentially like a CDN problem, right? Where you say, okay, I just want my trade to go to, whichever, ISP interchange is closest to me, and Netflix or YouTube or whatever has deployed into like every ISP interconnect on Earth, right? So I get like a 2 millisecond ping because it's literally going down the street, right? But the problem is that like we have a consensus mechanism, and we'll assume it's like PBFT Tendermint style, right? It needs to get 2/3 of the people. So if you have a geographically distributed like validator or sequencer set here, right, which ideally you should for like various reasons, regulatory not least of, you still need to wait for all of those people to come to a vote, right? Generally the ballpark is you're probably not getting like a right path in a non-BFT consensus algorithm sub 125, 150 milliseconds in like a global round trip for this. PBFT is probably, 2 to 3x slower. So like Solana is probably about at the limit of like where you're going to get for like a decentralized kind of consensus algorithm that's going to be kind of multi-rounds of voting here. And I'm probably incorrect on like some of the things on like how Solana's algorithm is going to work, but we're ballparking that. I don't think you can fundamentally solve that if you want to have a consensus mechanism on that. And to some degree, the point of a blockchain is to have a consensus over the state of it. How like a centralized rollup, would resolve that is just like we have one copy of the state. And it's probably not one copy, right? Like I'm assuming that like Optimism and Arbitrum have multi-availability zone things and they have backups and et cetera like that, right? But fundamentally you can say, well, there's one copy and it just goes there. But if you have to do consensus, you do actually have to hop around all of the nodes, whether those are globally distributed, to make sure they actually come to consensus. So unfortunately, I don't think you can do that. You could do something with like a rollup as a service provider where you could have essentially a sharded distribution of your thing and, rollups as a form of execution sharding where you say, well, I have my app. And if you're in London, you can use like the London app and that connects to like the London instance of the rollup. And these don't necessarily have shared states, but if, bridging gets to a point where it's kind of sufficiently easy to do, we get some of this DK stuff over the hurdle, you can say, well, I'm just going to go rebalance my assets and say, I'll have some of my assets on the London one. And, I'm going to go take a trip to Singapore. Well, when I land in Singapore, I'll do a bridging transaction, put my funds on Singapore, and now I'll trade on Singapore. But fundamentally, those would be like logically distinct state machines. And you might have kind of, this is the standard, right? Chicago Mercantile Exchange to New York Stock Exchange. There would be like an arbitrage gap between these two different state machines. But that would be a closer, I think, model to accomplish that. than having one large shared sequencer that's globally distributed, because they will need to come to consensus over that.
Okay, awesome. Thanks.
Great question. I want to make sure that we also touch on atomic interoperability, but I guess before that, I want to ask, like, how do you think about liquidity across all of these different app rollup chains? Like, do you think this is going to be a huge bottleneck to adoption? Or do you think this is going to cause certain rollup frameworks like Arbitrum Orbit or like OP Stack or whatever to have like a sticky moat?
Yeah, so I guess I'll first say I'm not sure if liquidity is the thing that will give an OP Stack or like an Orbit chain its moat. I think it's one factor right now, but I don't think that's actually like a thing that's like irresolvable, because fundamentally that's just like a bridging thing, right? The way that, you know, an Arbitrum or an Optimism have kind of liquidity on their chains is because to onboard liquidity to them, you just go, okay, I'm going to go buy ETH. I can buy ETH functionally anywhere, right? There are very few people who cannot acquire ETH on Earth, right? Whereas it, you know, even Solana got like pulled off of like Robinhood, right? So ETH has very, very high both depths of liquidity as well as, and I know the term is like just end user access to it. And then you can just in one hop, you can bridge from ETH up to the rollup instantly, right? And so your deposit to the rollup is very, very quick. That gives you this, you know, liquidity. So I'm not sure if the framework themselves give that. So, and this expands into my larger view of like, the big questions, I think, on liquidity between these rollups is going to be, what is the gas token they use? Because the kind of blocking factor on I want to go use a rollup is that I have the token I can pay on this. The analogy I've used a couple of times now is, you know, we saw the Bad Kids art or whatever got, you know, a little bit of hype for like a Cosmos NFT project, and people were like, oh, I want to go buy like a Bad Kids, right? And they're like, where is it? They're like, it's on Stargaze chain. They're like, what is Stargaze chain? You're like, oh, it's like an NFT specific Cosmos chain. They're like, cool. How do I use that? You're like, all right, well, you got to go buy, you know, if you're like a user in the US, you got to buy some Atom on Coinbase, deposit that on Atom, bridge that Atom over to Osmosis, swap that for some stars on Osmosis, which has about $50,000 of daily, like 24-hour kind of like volume on it. And then you can bridge that stars you bought on Osmosis over to stars and buy that. That is a lot of friction for like an end user to go buy a JPEG. When we think about a lot of these rollups, right, and it gets into this question of like, kind of, do you want to have your own sequencer, or does that sequencer want to have its own gas token, right? That sounds really nice in that, oh, I'll have my gas token, I'll accrue value to that token. That'll be really good for us economically. Okay, but you have to go provide liquidity on that token. You have to get it listed on exchanges, both decentralized and centralized. You're going to have to go call Fireblocks and every other institutional supporter to try to get large quantities of money onto that. That's a really hard game to play. And I think it's one of the reasons we see rollups will probably continue to use ETH. The biggest test case I think we'll see for if there's an evolution out of that, Starknet has at least listed on their website, you know, right now you go use Starknet, right? You pay your fees in ETH. There is at least statement on Starknet's website, and I think it was like Eric Wall was tweeting about this yesterday, that they intend to eventually use like a Stark token or whatever, right? And they would use that for gas. That's something that's coming late in the game, right? Starkware's been around for like a while. Starknet's been live for like a while, right? Whether you can do this evolution for your token after you have PMF, or whether you do the Optimism Arbitrum method where you say, well, we're going to mint a token because we need a token for like, you know, various economic things, but we're just going to use it for governance things rather than for gas tokens. That was a little bit long and rambly and off track, but I do think to get back to the point of like the Orbit chains versus like the OP stack and whether the frameworks are going to give them moats, it's not going to be based on liquidity. It's dev tooling. Fundamentally, like we're all in the game of dev tooling. Why is the EVF in here? Because people know how to build on top of the EVF, because there's tooling to build on top of the EVF, because I can Google how to write a smart contract on the EVF, and there are sufficient things. I can go ask ChatGPT. ChatGPT knows how to write a smart contract on the EVF. It will tell me the instructions to use DApp tools or Foundry to deploy a contract to the EVF. That's like worth something, right? Buying new kind of developers onto a new platform is like horrifyingly expensive, right? You know, we're starting to see a lot of hype in Rust. Like I was writing Rust in like 2014, right? No one knew like Rust existed in like 2014. It's been like a 9-year long thing to get it to the point where like, oh, this kind of niche language is at least known to exist.
Right, this makes sense. I totally agree with you that developer experience is a big differentiator over here. So I think that's all the time we have. Thanks so much, Josh. I think that gave us a great overview of sequencing and specifically the kind of place that shared sequencing has in the modular stack conversations. That was awesome.
Thanks so much for giving me the time.
Yeah, thanks.